Hello and welcome to day 3 of Advent of Code. Another day, another puzzle. Let's start and read the text. So, day 3, binary diagnostic. The submarine has been making some odd cracking noises, so you ask it to produce a diagnostic report just in case. Seems like we are still in the submarine theme. The diagnostic report, your puzzle input, consists of a list of binary numbers, which, when decoded properly, can tell you many useful things about the conditions of the submarine. The first parameter to check is the power consumption. You need to use the binary numbers in the diagnostic report to generate two new binary numbers, called the gamma rate and the epsilon rate. The power consumption can then be found by multiplying the gamma rate by the epsilon rate. Okay, so again, two values and multiplying to get the solution, okay. Each bit in the gamma rate can be determined by finding the most common bit in the corresponding position of all numbers in a diagnostic report. For example, given the following diagnostic input, bunch of binary numbers. Considering only the first bit of each number, there are 5 0 bits and 7 1 bits. Since the most common bit is 1, the first bit of the gamma rate is 1. The most common second bit of the numbers in a diagnostic report is 0. Okay. The most common value of the third, fourth, and fifth are 1, 1, and 0, respectively. And so the final 3 bits of the gamma rate are 1, 1, 0. So the gamma rate is the binary number 1, 0, 1, 1, 0, or 22 in decimal. The epsilon rate is calculated in a similar way. Rather than use the most common bit, the least common bit from each position is used. So the epsilon rate is 0, 1, 0, 0, 1, or 9 in decimal. Multiplying the gamma rate, 22, by the epsilon rate, 9, produces the power consumption, 198. Use the binary numbers in your diagnostic report to calculate the gamma rate and epsilon rate. Then multiply them together. What is the power consumption of the submarine? Be sure to represent your answer in decimal, not binary. Okay. Let's look at this again. The gamma rate is the most common value of each bit position. 22 in decimal in this example. The epsilon rate is calculated in a similar way. Rather than the most common, the least common bit from each position is used. Okay. Now I'm wondering, is this always the reverse? Like 0, 1, 1, 0, and this is 0, 1, 0, 0, 1. Is this always the case? Because the bit can only be the most common or the least common. Except in situation where it's the same, and I hope this does not exist because that is not really defined here. So that's the epsilon rate, or 9 in decimal. Multiplying 22 by 9 produces 198. Okay, this seems doable. Let's look at the input. Okay, can save this file. Let's switch to IntelliJ, and input in. And then let's rename it to day 3. And we will again not clean this up, not yet, and just create a day 3 file. All right, awesome. Then let's, like always, start with the main function, and then part 1 and part 2. And we will call part 1 first. Oh, I see. Those names are shared between the files in the same package. Should we start creating packages? We could. Or should I just rename them? Did I create packages? Maybe I create packages because I think those things will get more complex, and then we might want to split things into more files, and then a package might be helpful in any case. So do this for all the things. So after all, we will clean up a bit. 2, 8, 3. Awesome. And okay, still complaining. Oh, because we moved it to folders, but we didn't actually use it as a package. This is different between Java and Kotlin. Java, the folder name will always dictate the package name, and here that's not the case. Although I've never seen the case where you have different package names than the folders. Well, okay. Again, we need to read the input. And we still haven't created a utility function. And I wonder if we even want to do this. So how do we want to represent the data? I assume since we just need to count which one is the most common character, we might just leave it as a string. Then once we construct the result, we will turn it into a decimal number at the end. Yes. And until then, we keep it as a string, hoping that in part 2, this won't be a problem. Okay, let's see. We want to read day 3. And just to make sure this works, let's run this once. Get the data again. There was always a... Yeah, let's get rid of this. We do not... Does it run? Does it build? Doesn't look like it, so let's try this again. Okay, now it's building. And then let's think about the most fancy way to split this. Okay, we got all the values. Awesome. Should we... What's the most useful way to sum those up? We could just create a map, I guess. Let's see. So one idea, my first idea, maybe not the best, but one that should work, I hope. We'll create a list, and for every item, instead of... So right now it's... Let's actually look at this. Right now it looks like this. One entry in the array. What if we turn this into every entry is a list as well? And then we first I was thinking about... No, that doesn't make any sense at all. I don't need to look at single numbers. Or do I? I want to let's think about the simplest way to do it before we do it fancy. We need to count for every position the ones and zeros. Either we do this by having something like a count for every position, like for position 0 we have 15 zeros and 2 ones. Like we build up this list of counts and then just to figure out what the gamma rate is by looking at every position and picking. Or I guess another way how we could do it, for every zero now we are representing this as 2 values. We could maybe even try to represent it as 1 value. Like let's say for every 0 we do -1, for every 1 we do +1, and then at the end we see, is it a negative number or a positive number? That might work too, except if part 2 wants us to do something else with those numbers, then we might have a problem. Let's try to count one first. What kind of data structure do we need? We need either a list or an array, or let's see, let's define it. How would we define it? An array of, should we just use a pair maybe? Sorry, pair of 2 numbers, and maybe we can even make it a list. But a pair itself is I think, to mutate the entries in the list. Let's create data class. Okay, that is getting weird, but once. Yeah, let's do it. Let's do this. Probably not super nice one, but we want a list of counts. And it's even fixed size list because it's as long as the lines. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? It even says here 12. Should we just create a list of 12 entries? For part 1, that might be just enough. Is there a list builder that lets us do this without writing count 12 times? Okay, look that up. Kotlin list builder, something like this. Build list. Builder action. Okay. This just adds things. Almost, yeah. I want more something like times. Kotlin times. Not for ints. repeat. Kind of. Kotlin create list with fixed and values. No. Generate sequence. Take 4. That is exactly what we want. Generate sequence, and then it will just create a count. Okay. Create. We take 12 and create immutable. Does even need to be mutable. Create a list from it. Okay. Wow, that took a while. So this is our data representation. Now we have a list of counts. 20 just fixed to 12. Let's see if this will work in part 2. And now we sloop over the data. We have a line, and then for each line, look at the character, I guess. That does not work. We need the index for each index. Index character, and then we look at counts at index. First we need to probably look at when, no, counts at index. Ones or zeros, yeah. Alright. Yeah. So if this is a 0, counts index plus plus. So 1 character, not a string. Then we increment the ones. I'm really not happy about the data structure, to be honest. That is really complicated, but let's see. It should still get us there. I don't see a problem with getting to the solution, but it's definitely not the nicest thing. So let's print the counts and see if it did what we expected it to do. We got a bunch of counts. Doesn't look bad. So now let's calculate the gamma and beta rate. So now we loop over the counts. If, or maybe we can just map it. Yeah, gamma. Let's take a quick peek. Is it the gamma rate actually? Gamma rate. The most common. Counts. And then we counts is bigger than, sorry, one, oh, so count once is bigger as count. So 1, it's if count zeros is count once, then it's a 0. And if it's nothing, so they're equal, What was the name of the thing we are looking for? No most common bit. Let me just throw an error. Print gamma ray. Okay, we have a gamma ray. Awesome. In this case, we might even join this to an string. Join to string. Anything. Oh, the default is apparently with join with commas. We just want to join it to number. Awesome, and now we need the epsilon rate, which should be exactly the opposite. So should we just, what's the easiest way to flip it? Epsilon rate. We could just map the gamma rate, I guess. Why is it complaining here? Our chain might. Oh, join to string can also take. What? Write a string from all the elements separated using separator and using the given prefix and postfix. If the collection could be huge. Where's the... Oh, a transform. Yes. And then we take the gamma rate. Just... Maybe just flip it manually by just looking at the string. And character is 0. So 1. So 1. It's a 0. And if it's neither, throw an exception. And now we can print it if we write it correctly. Oh, okay, it's a bunch of characters now. We want to join this to a string again. Done. Done, because we picked the wrong separator. Awesome, and it's exactly flipped. If that would be a binary number, it would have been easier to flip. Essentially, we just would need a not, I guess. But now we need to turn it into numbers. Let's get some coffee. The nice thing is we won't need to do this ourselves, like Kotlin definitely, or even Java would have something for that. So Kotlin binary to decimal. And it's a binary string even. Let's see. Integer pass int, and then we can give it radix. That looks awesome. Let's rename this as raw, since it's not actually the rate just yet. And then let's see. Gamma rate equals gamma rate raw Okay, integer, pass in 2, and the same for the epsilon. And let's even validate this. Gamma epsilon okay, so this should be 284. Let's just throw this into Google and see if it can do this for us. Oh, I was expecting a quick answer to show up, but what is this exactly the number? What? Okay, 284. Okay, that seems to work then. And to print it, the result of the multiplication, gamma right times epsilon right. That would be this number. Let's see. Close, 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 input. Right answer. Awesome. Let's see what part 2 is about. Next, you should verify the life support rating, which can be determined by multiplying the oxygen generator rating by the CO2 scrubber rating. Okay. Both the oxygen generator rating and the CO2 scrubber rating are values that can be found in your diagnostic report. Finding them is tricky. It's the tricky part. Both values are located using a similar process that involves filtering out values until only one remains. Before searching for either rating value, start with the full list of binary numbers from your diagnostic report and consider just the first bit of those numbers. Okay, before searching for either rating value, start with the full list of binary numbers from your diagnostic report and consider just the first bit of those numbers. Okay, let's maybe take some notes. And I almost wonder if we should just continue here, but let's see. First bit of numbers. Then keep only numbers selected by the bit criteria for the type of rating values for which you are searching. Discard numbers which do not match the bit criteria. Okay. Only the first bit. But then only those that are somehow important. If you only have one number left, stop. This is the rating value for which you are searching. Otherwise, repeat the process considering the next bit to the right. Consider just the first bit of those numbers then. Keep only numbers selected by the bit criteria for the type of rating value which you are searching. Okay, so we look at the first bit, filter the list down, and if we only have one number left, wait, that's the number we need. If not, we use the next bit, filter the list down. At some point we should end up with, if I understand this correctly. Let's see, the bit criteria depends on which type of rating value you want to find. To find oxygen generator rating, determine the most common value, 0 or 1, in the current bit position, and keep only numbers with that bit in that position. If 0 and 1 are equally common, keep values with the 1 in the position being considered. To find CO2 scrubber rating, determine the least common value, 0 or 1, in the current bit position, and keep only numbers with that bit in that position. If 0 and 1 are equally common, keep values with the 0 and the position being considered. For example, to determine the oxygen generator rating value using the same example diagnostic report from above, start with all 12 numbers and consider only the first bit of each number. There are more 1 bits than 0 bits, so keep only the 7 numbers with a 1 in the first position. Only the first. There are more 1 bits than 0 bits, yes. So keep only the 7 numbers with a 1 in the first position. Okay, so we should have split this, I guess, into function that can give us the value for just one position. So we don't have that from the first part, so we rewrite this. Then consider the second bit of the 7 remaining numbers. There are more 0 bits than 1 bit, so keep only the 4 numbers with a 0 in the second position. Okay, third position, 3 of the 4 numbers have a 1, so keep those 3. Fourth position, 2 of the 3 have a 1, so keep those 2. Then we have this. There's only 1 number left, stop. The oxygen generator rating is 0, 1, 0, 1, 1, 1, or 23. Then to determine the CO2 scrubber rating, and then we look for the fewer bits. Okay. Finally, to find the life support rating, okay, we multiply those. Okay. Let's first think about how the algorithm would work in code. So, have a list of numbers. And then have a position. It almost sounds like a recursive function. So let's maybe write this. Find rating. So we pass in a list of values, and it's still the string, I think. And in this case, a list of those things. Then a position we are currently looking at. And this is this one, for example. And we return a string, which is the one single number we wanted. So if we would say is it filtered? Do we filter the list here? I think. Yeah. So first of all, we need to determine the count for this position, right? Almost what we did here, except that we do this for all positions. Like here, so we need to find counts, give it again the list and position, and then we would do create one of our helper things. Maybe it is useful after all. Return the count. And then we go over all strings. A line. Then we only look at the character at this position. here. So it is over, and our character is then at the given position. Say count 0 and 1s. And with that we can get the count. So find count. Find count. Okay, not the best naming. So with that we have the count at the position, and now we need to either get bigger or small. And it depends on which rating we are looking for. So pass this in. We need a filter, and the filter will receive a string, which is the convert, and the count, and it needs to tell us, do we want this value or not? So filter the values using the filter we. Okay, we need to write a custom one. And then we filter by call count. So this will just give us the filtered down list, depending on whatever we passed in, and then we say filtered values is this case or smaller than 1. Say 1. If it's that, then we can just pick this one value can just take this one value and return it. That's enough, maybe. If it's larger than 1, do the same thing again with the filtered values. The position moved and the same filter. And if it is smaller than 1, then we throw again, because that is something that should not happen. And then we move the return out. Okay. So this allows us defining our filters for part 2. I hope. We didn't make a mistake, but let's find out. So we need our values again. Where are those? Those. And now we say, what's the first one? Oxygen rate. Oxygen rating. Is, and it's a raw value again. Find rating. Our values. We start at position 0. And now our filter our filter gets and count. Oh, and we need the position, I guess. Because otherwise we cannot make a decision. Or do we? Okay, so we get a value, position, and a counter. Now we need to make a decision. And create a helper for that. Oxygen bit. So we get a count and it needs the biggest. Find oxygen rating is the highest, the current bit, and keep only that bit in the keep common. Keep values with a 1. Okay. So that's something we already wrote somewhere over this here. If it's a 1, then it's a 2, it's a 0, otherwise it's a 1. So you add position is value. And then want to keep this if value at position equals oxygen bit discount. And now we print. So our filter looks at the current position and compares it with the oxygen bit for this position. Let's see. Okay, there's okay. To pass in the position. For coffee. Nice, we got a value. Let's print this. So for oxygen, sorry, oxygen, we got the oxygen rating. We turn it to an integer. And now we need to do this for the CO2 scrubber rating. So let's call the CO2 rating. We want to find the rating in the list of values. We start at 0. We need a different kind of filter though. Now we are looking to compare it with the CO2 bit. Find CO2 bit for this count. Give it to us as a character. So let's see, the least common value. And otherwise it's a 0. Okay. If count once is smaller. Is it just this one again? Well, to be safe, let's just write it explicitly. It could be that we could just reverse this again. If are smaller than count. Oh, sorry. If the ones are smaller, then we take the ones. If the zeros are smaller, else it's a 0. Compare this with position equals this, and this is the raw rating again. CO2 rating equals fastest. Then we can print. Let's print it. Nice. I am kind of optimistic just because we did not hit any of our exception cases and we actually end up with numbers. So that looks good. Let's print the solution and see. Oxygen rating times CO2 rating. See, that is what we need to do, right? So run it, get this number, and it is the right answer. Awesome. Awesome. It feels a bit hacky, like there are a bunch of things that are definitely not the best solution. And we also process the numbers or values always as a string, which kind of works well enough for this case, but we could also do a bit shifting, I guess, to figure things out. And we do a lot of work twice. For example, we first calculate the oxygen rate, and then we loop over all the things again and calculate the CO2 rate. I guess we could do this in one go, but the data set is small enough to just do it this way. Yeah, I'm curious how you solved the problem. What kind of language did you use? Is it more fancy than this really raw solution? Let me know in the comments, and yeah, see you tomorrow. Bye bye.